Good day, everyone. We are looking at factors and remainder theorems for mathematics level 4. So I've put some 6 simple problems that we'll go through. They look many but very easy. The first one says prove that x plus 3 is a factor of the function given to us there. The next one is just like the first, but still proving that x minus 3 is a factor of this function. Then we will determine the remainder when f of x is divided by x minus 1. Then we'll calculate q if x plus 3 is a factor of a function given. Then we'll calculate n if this function gives a remainder of -7 when divided by 2x plus 1. And finally, what must be added to f of x so that 2x minus 1 is a factor. So, just a brief background of factors and remainder theorem. What we must know is that in factors and remainder theorem, whenever you read the problem, check whether have you been given two functions. Like you see, there will always be two functions because the target is that you're given two functions. There is a bigger one that is dividing a smaller one. How do you know the smaller one? You study the degree. The degree is the highest power of x. Here it's 1, here it's 3. So that is obviously the smaller one, x plus 3. So the target is that you have to follow some 2 steps. Step 1, you equate the smaller function to 0, which is going to help you solve for the root. If I get x equal to a, for example, it will be the root. It will be a depending on the degree of this function. It can also be two roots, like x equal to a, x equal to b. Then step number 2, you calculate a remainder. And how do you get a remainder? You take the root that you got from the smaller function, you put into the bigger function. So if your remainder gives you 0, then you're under the factor theorem. If it doesn't give you 0, you're under the remainder theorem. So this is basically what this elementary factor and remainder theorem is talking about. So let's now go to the first problem. The first problem here requires of us to prove that x minus 3 is a factor of f of x. So I was saying I like to call my bigger function f of x. If they are not given names, you can put it that way. So that is my f of x. Then my smaller function will be x plus 3. So as I explained earlier, f of x is the bigger one because its degree, which is the highest power of x, is 3. Here is 1. So I will do my step number 1, which will say let x plus 3 be equal to 0. If I equate x plus 3 to 0, then I will solve to get x equal to -3. This is what we call a root. Then in my step number 2, I will be calculating a remainder. And how do I get the remainder? I substitute the root into the bigger function. So that is how I get my remainder. If my remainder gives me 0, then g is a factor of f. If not, then it's not a factor. So I will then do my calculation. In the place of x there, I'm putting -3 plus 5 into -3 squared minus 18. So I will then use my calculator to figure out what does it give me. So -3 cubed is -27, -27, then -3 squared is 9, 9 times 5 is 45, then minus 18. So what I see, it's a 0. So immediately I see a 0, my conclusion should be that x plus 3 is a factor of f of x. So that should be my conclusion. So that is also indicating to you that you are under the factor theorem, because when you are under the factor theorem, you pick it up by the remainder giving you 0. So that was our first problem. Let's now go to the second one, which is more or less like the first. It's just a little bit tougher because instead of just a negative x minus 3, we're now getting x minus 3a. So this shows to us that this is our two functions. So once I pick my problem, I identify that I'm seeing two functions all the times. So my first function, I always like to call the bigger one f of x, is x cubed minus 6ax squared plus 11a squared x minus 6a cubed. then my smaller function, smaller simply because the power of x is just a 1, but here the power of x is a 3. So I will say let my x minus 3 a equal to 0. So it will show me that my root is equal to 3, 8. So that's my step number 1. I always equate the smaller function to 0. Then I get a root. I put in the bigger function. If you've got 2 root, then you put the 2 root into the bigger function. So I can now go for my remainder, which will be f of 3a. And what that means is that I will substitute 3a everywhere there is x. So I'm getting my 3a cubed minus 6a into 3a squared plus 11a squared into 3a, then minus 6a cubed. So that is what I get. Then from here I simplify. If I simplify, 3 cubed is 27, so I'll get 27a cubed. Then 3 squared is 9, 9 times 6 is 54. So I've got negative 54, a squared times a gives me a cube. Then 11 times 3 is 33, a squared times a gives me another a cube. Then finally minus 6a cube. So from here, all I need to verify, because you see a cube is everywhere, is whether 27 minus 54 plus 33 minus 6 is a 0. So if I try that, I'll take the positive numbers first, 27 plus 33, then minus 54 minus 6, so that gives me 0. And my conclusion is that x minus 3a is a factor of f of x, since I decided to call my function f of x. So guys, that is how simple it is. So we can now go to the third. So you see that for the first and second, I've succeeded to prove that the smaller function is a factor of the bigger one in each situation. So the third problem is saying determine the remainder. So now there is a keyword here called remainder. So this is now telling you that when you follow the 2 steps, your remainder will no longer be a 0. When you see keywords like factors, divisible, or root, then your remainder will always be a 0. So I need to determine the remainder when f of x is divided by x minus 1. So my f of x is given to me as 2x cubed plus 3x squared minus 4x plus 5. So that is it. Then my smaller function, I will call it x minus 1. I will let the smaller one to be equal to 0. That leads me to my root, which is 1. Then I'll calculate my remainder, which is f of 1. That means I go to the bigger function, I'll place every x by 1. So this will give me 2 into 1 plus 3 into 1 minus 4 plus 5. So if you do this calculation, this is 5 plus 5 is 10. 10 minus 4 is equal to 6. So you can therefore see your remainder when f of x is divided by x minus 1. So this time the remainder is no longer 0. So we can no longer declare that g is a factor of f because the remainder is not 0. Then we can go to number 4. So number 3 was on the remainder theorem. Number 4 now is gradually bringing us into applications. It says we should calculate the value of q if x plus 3 is a factor of the other function. So underlining things that are important to me. I must always see 2 functions given to me. Then the word factor is reminding me that my remainder will be a 0. That is to say, I'm under the factor theorem. So I will pick my f. My f is 2x cubed plus x squared minus 5x minus q. So that is my bigger function. Then, so as I was saying, I've picked my f of x, which is my bigger function. Then I have to go for the smaller function. My g is x plus 3. So that is my smaller function. This time we are solving for q. So this is like application problem. You can see why I underlined the key things there. So I will follow my same 2 steps, but in the position of r, I will put in 0 because they use the keyword factor. So I will start by saying let x plus 3 be equal to 0. It will give me my x as negative 3, which is my root. That's my step number 1. The usual step 1 and step 2. We are calculating the remainder, which requires us to go into the bigger function. We'll place our x by a negative 3. But because of that keyword factor, here they are not proving. We've already been told that x plus 3 is a factor. So whenever it's a factor, it means your r will be 0. It's the same thing as if we were told that f of x is divisible. Divisible, root, factor, the keyword that we use them under the factor theorem. So we are making our r 0. Then on the other side, we replace every x by negative 3. So on the other side, I'm now going to replace every x by negative 3. So this is 2 into negative 3 cubed plus negative 3 squared minus 5 into negative 3 minus q. So you see I'm now applying the factor theorem. So q is not a like term to all of this. So this q has to cross over to the left so that it can become a positive number. Then I will take my time on my calculator and do the rest. So negative 3 cubed is negative 27 times 2 gives me negative 54. So I get negative 54. Then 3 squared is positive 9 plus 15. So that leads me to negative 30. So, ladies and gentlemen, you see I've succeeded to solve the value of q by using the factor theorem. So, we are done with the first 4. We can now go to number 5. So now we are looking at number 5. Question number 5, if you still remember, it was saying we should calculate n if f of x 6x cubed minus mx squared plus 12x plus 3 gives a remainder of 7, of negative 7. So they use the word remainder there of negative 7 when divided by, I'll call this function g of x, which is 2x plus 1. So that is what question number 5 was basically talking about. So we need to calculate the value of n. So it's basically like number 4. Number 4 was applying factor theorem. That's where they use the word factor. If you listen to it, x minus 1 was a factor. Now we are under remainder theorem, and our 2 functions are still given to us. The smaller one here is 2x plus 1 because the degree is 1. The bigger one is the one with the degree of 3, which is the highest power of x. So I will start with my first step, which I will be letting my smaller function to be equal to 0. Then if I solve for x, I will get negative a half, which is always called a root. Then step number 2, I calculate the remainder, which requires me to put the root into the bigger function. So if I'm doing that, then all I will basically do now is that we're not being told to calculate the remainder. The remainder is already given to us as negative 7. So in the place of r, we are putting negative 7. Then on the other side, we'll replace every x by negative a half. So this will be 6 into negative a half cubed minus m into negative a half squared plus 12 into negative a half plus 3. So from here, you see yourself with an equation that has only n as an unknown. So if I try to simplify that, I'll get negative 7 is equal to negative a half cubed is negative 1 over 8. So this becomes negative 6 on 8. Then negative a half squared is positive 1 over 4. but there is a negative here, so we'll get 1 over 4m, then a half of 12, I'll get negative 6, because of that negative, then plus 3. So I'm going to carry the like terms of negative 7 that side, so that means negative 7 will be adding to 6 over 8, so I get negative 7 plus 6 on 8, then negative 6 will be going as positive 6, and 3 will go in as negative 3, so that on the left side, I'm seeing myself with negative 13 over 4 is equal to negative 1 over 4m. So I will now divide both sides by negative 1 over 4. So I've got negative 13 over 4 here. If I divide by negative 1 over 4, that leads me to m being 13. So that is how we've applied our remainder theorem, just like we did with the factor theorem for number. So, ladies and gents, let's have the last one, which was saying what must be added to f of x. So we're given f of x as 6x cubed plus 35x squared plus 5x minus 8. So what must be added to that f of x so that 2x, which I'll call it my g, 2x minus 1 is a factor. So if you can interpret that question well, it means as for now, g is not a factor. We need a number that if we add to f, it will make 2x minus 1 a factor. But because we've got two functions, our procedure is the same. Smaller function, you equate to 0, solve for the root, put into the bigger function to see your answer. So I will start by saying let 2x minus 1 be equal to 0, so my root is a half. That is the normal procedure. Then I will now go to the calculation of the remainder, which means I'll go into the bigger function. I'll place every x by the root. So if I do this calculation, then I'll get 6 into a half cube plus 35 into a half square plus 5 into a half minus 8. So my calculation will lead me into what? The first thing will be 6 on 8, since a half cube is 1 over 8, then plus 35 on 4, since a half square is 1 over 4, then plus 5 over 2, a half of 5 is 5 over 2, then minus 8. So once I do that, we'll clearly see that our remainder is 4, which is the reason why I said from the beginning, if you interpret this question well, it's just telling us that g is not a factor. You need to add something here to make g a factor of f. That's why you're clearly seeing that when f divides g, there is a remainder of 4. So to get that number that when you add up there into f, it will make g a factor, you need a number that can make this remainder 0. So since this remainder is a positive 4, it is only by subtracting 4 from it that you see 0. So that number to add into f of x should be the negative 4 that will make this remainder 0. So I'll therefore say I need to add negative 4 to f of x to make 2x minus 1 a factor of f of x. So if you want to verify that, if you add negative 4 there, you see that negative 8 minus 4 will be negative 12. So if you repeat this calculation, putting negative 12 there, you will take it to a 0. So, ladies and gentlemen, that is how elementary problems of factor and remainder theorems are. Thank you very much.